So in an earlier section, we looked at measures of the center of the data. Here in section 2.7, we're going to look at measures of the spread of the data. So the first measure is called the range. It's a very rough measure. It's just the high value minus the low data value. So again, the range is just a rough measure of variation in the data set. The range is not a very good measure in that it's affected by extremes. If you have an extreme high, extreme low, then you could get a distorted measure for range. Also, since it only uses two values instead of all of the values, it's again giving a very rough estimation of variation. Well, let's find the range for the data set 1, 4, 6, 8, 11. So here our range is just going to be the 11 minus 1, so max minus min, which is 10. So that data is spread over 10 units. So one advantage of the range is it's really easy to figure, super quick. Now we want to look at a better measure of variation in the data called the standard deviation. So first we define the deviation from the mean. So the difference from the mean is just the data value x minus the sample mean x bar. So it's difference between value and the mean. Next we want to form something called the sample variance, which is the mean of the squared deviations. But you use n minus 1 in your divisor. So you don't divide by the number of values, but 1 less than the number of values, where n again is your sample size. And then your standard deviation is the square root of the variation. So altogether that formula looks like this. So what's going on is x minus x bar, that's a deviation. We square it, so all our deviations are positive. That way when we add them up, remember the sigma here means sum. When we add them up, we don't get any canceling. And then you did the sum of the squared deviations divided by how many, that's an average. And since we squared our deviations here to get the standard deviation, we undo things by taking a square root when we get done. Some notes here. Standard deviation is always greater than or equal 0 because all the things that go into it are going to be greater than or equal 0 because they're all squared. And you take a square root, that's greater than or equal 0. Higher standard deviation, I'm using SD for standard deviation, indicates more variation in the data. And a lower standard deviation indicates less variation in the data. And it's variation around the mean. Also note that the standard deviation is affected by extreme values. So if you have an extreme value, then that's going to have a very large deviation from the mean. And so that's going to add to the standard deviation. So standard deviation adds significantly to the standard deviation. So it is affected by extreme values. So let's actually go ahead and compute here. So we're going to use the same information, our same data set that we did above for the range. We want to find our sample standard deviation of 1, 4, 6, 8, and 11. So I've organized how to find this standard deviation by using a table here. So I listed the x values in the first column, and then we'll list the mean in the second column, and then the deviation in the third column, and then we'll square all those entries in the fourth column. And then in the bottom row, we'll put our sums. Well, this lower right-hand corner, the sum of the x minus x squared, x bar squared column, that's the numerator in our standard deviation formula. So first, let's find our mean. So our x bar is going to be 1 plus 4 plus 6 plus 8 plus 11, and we'll divide by 5. Which is 30 divided by 5, or 6. So 6 is our x bar, so that goes in our second column there. And now x minus x bar, we just subtract left to right. 1 minus 6, negative 5. 4 minus 6, negative 2. 6 minus 6, 0. 8 minus 2, 2. 11 minus I'm sorry, yeah, 8 minus 6, 2, 11 minus 6, 5. So those are the deviations. So now notice here we've got a deviation total of 7 below the mean and 7 above the mean, so this sums up to 0. So that's why we squared this, because if we didn't square and just added up the deviations, we'd always get 0. So now we square all these numbers. So negative 5 squared is 25. Negative 2 times negative 2, 4. 0 squared, 0. 2 squared, 4. And 5 squared, 25. So that gives us a sum of 58. So now let's go ahead and form our variance. So our s squared is the sum of x minus x bar squared. That's right here. That's the 58. This is the sum of the x minus x bar squared column. So that's our numerator. And then we are dividing by n minus 1. So we've got 5 data values here. So we're dividing by 5 minus 1, 4. And if you do the calculator work there, you'll get 14.5 for that value. And then the standard deviation is just the square root of 14.5. Which is 3.81 to 2 decimal places. So there is our standard deviation, our measure of variation. To figure this on the TI-84, you just use stat edit to enter the data into a list and then do one variable stats. So let's do that real quick. So I'm going to go to stat and edit. Let's clear out our list. And then our values here are 1, 4, 6, 8, and 11. Then I go to stat, arrow to the right to calc, press enter. List 1 is what I want there. Highlight calculate, enter. Here's our standard deviation, SX 3.807, 3.81, and that is what we got here.